All right, let's talk about the biggest revolution happening in cars right now. And I bet it's not what you think. We hear a ton about batteries and charging and range anxiety. But the real story, the one that's completely changing what a car even is happening deep inside. It's a total reinvention of the car's brain and its nervous system. And it's all being driven by some incredibly powerful AI. So let's just get this out of the way right up front. The most profound, game-changing shift in the auto industry isn't about how we power the wheels. It's about the shift from a car being a machine that's mostly mechanical to a car that's basically a powerful, centralized computer that you happen to sit inside. Yeah, the real revolution is happening in the silicon. Okay, so let's start at the surface, the stuff we can actually see and feel. We're starting to see these amazing AI-driven features that are so much more than just a glorified cruise control. This is kind of like the most visible layer of this whole technological onion we're about to peel back. And that is the big question, isn't it? The term self-driving gets thrown around constantly, but what does it really mean for a car you can actually go out and buy today? Well, the truth is, the capabilities really vary. So let's take a quick look at two of the heavy hitters who are really pushing the envelope here. What's really fascinating here is just how different their philosophies are. You've got Tesla with its full self-driving, which is incredibly ambitious, right? It's trying to do point-to-point city driving using only cameras. Then you have Rivian's system, which uses a whole suite of sensors, cameras, radar, even LiDAR down the road, for super robust hands-free driving on the highway. But here's the real kicker. These incredible features are just the tip of the iceberg. They're only possible because of a massive revolution happening deep inside the car's electronics. So let's peel back that first layer. To make all that AI magic happen, to process an insane amount of data from all those sensors in real time, you need a brain, a really, really powerful centralized brain. And that brings us to what's called the high-performance computer. You see, in the old days, every single new feature in a car, the power windows, the ABS, you name it, it got its own little tiny computer called an ECU. But for something as complex as autonomous driving, that system just completely falls apart. The HPC is the solution. It's a single, powerful brain, a central command hub that can juggle everything at once. It is a total game changer. So what kind of hardware are we talking about here? Seriously, think of a high-end gaming PC, but on steroids. You've got your multi-core CPUs for all the general housekeeping tasks. You've got beefy GPUs, yeah, just like in a graphics card, to crunch all that visual data. And then you have the secret sauce, specialized AI accelerators built for one thing and one thing only, running the massive calculations needed for machine learning. This combination lets one single box handle everything from your safety systems to the Netflix app on your dashboard. And of course, this has totally opened the door for the big tech giants to jump into the car world. Companies like NVIDIA, the folks who make your video games look amazing, are now designing these absolute monsters of a chip, these supercomputers that act as the car's brain. They're custom-built to take in all that sensor data and run the incredibly complex AI models the car needs to make sense of the world around it. Okay, so we've got this amazing new brain. Awesome! But a brain in a jar doesn't do much good, right? It needs a way to talk to the rest of the body. The sensors, the motors, the steering wheel. The old way of wiring a car was, well, it was a mess and it just couldn't keep up. The car needed a brand new nervous system. To really get why this was such a problem, just look at this number. It's kind of nuts. Before this big shift, a high-end car could have over 150 of those little individual computers, those ECUs we talked about. It was creating an absolute nightmare of complexity that was just becoming unsustainable. And all of those little computers with all of their wires led to this. The wiring harness. Literally just the bundles of wires could weigh 70 kilograms. That's over 150 pounds. It became one of the heaviest and most expensive parts in the entire car. It was clear that something had to give. And this chart just illustrates the solution so perfectly. We're moving away from that chaotic, messy, distributed architecture on the left to the much cleaner, much smarter zonal architecture on the right. So instead of every little sensor having its own private wire running all the way across the car, you now have a few zonal controllers that act like regional managers. They collect all the info in their zone, like the front bumper, for instance, and send it all back to the main brain on one single high-speed cable. It's genius. The result is way less wiring, less weight, and a system that's actually built for the future. And this isn't just some theory. This is happening right now. You're looking at a real-world example here. It just shows how this zonal design creates this incredibly clean, logical, and modular platform. It's just an elegant solution to a problem that was honestly holding back innovation for years. But all this new architecture needs a new way to get its juice. So we've got the new brain, we've got the new nervous system. The last piece of this hardware puzzle is the bloodstream, the power delivery network. Because all this new high-performance tech is really, really thirsty, and the old system just couldn't quench that thirst. For decades, cars have run on a simple 12-volt electrical system. And look, that was fine for running light bulbs and a radio, but it is completely out of its league when it comes to a modern vehicle. Things like fully active suspension or steer-by-wire systems, they need way more power. The answer is moving to a 48-volt system. It basically lets you send the same amount of power using a lot less current. And that means you can use thinner, lighter, and cheaper wires, which, hey, helps solve that massive weight problem we were just talking about. And with a higher voltage system, you need a much smarter way to protect everything. So say goodbye to those old school fuses, the ones that literally melt and you have to go dig through a box to replace, and say hello to the e-fuse. This thing is basically a tiny intelligent circuit breaker that's controlled entirely by software. Now, this is where it gets really cool. E-fuses make the car's electrical system proactive, not reactive. They are thousands of times faster than an old fuse, which means they can prevent damage before it even happens. If one trips, no problem, a software command can reset it. They can even report back on how healthy a circuit is, which allows for predictive maintenance. And my favorite part, if the car's battery is running low, the brain can tell the e-fuses to temporarily and intelligently shut down power-hungry things, like your seat heaters, to save every last bit of range. How cool is that? Okay, let's pull all these threads together. We have a central superbrain, a clean zonal nervous system, and a smart power network. So why? What is the ultimate goal of all this new hardware? The answer is both simple and honestly profound. It's all to turn the car into a platform for software. This right here is the grand vision, the software-defined vehicle, or SDV. It's a fundamental change in thinking. The hardware you buy is no longer the finished product. No, the hardware is just the foundation. It's a platform. And on top of that platform, car makers can build and deploy new features, performance upgrades, you name it, all through an over-the-air update, just like you get on your smartphone. And to pull that off, engineers borrowed a big idea from the IT world called a service-oriented architecture. So instead of having one giant, clunky piece of code that runs the entire car, which would be a nightmare to update, every function is its own little independent app or microservice. The brakes are a service, the climate control is a service. They can all talk to each other, but they can also be updated or even replaced one by one without breaking everything else. The easiest way to think about all this software is like a 3-layer cake. On the bottom, you have the infrastructure layer. That's the basic stuff that just lets the software talk to the hardware. In the middle, you have the application layer. That's where all those cool little microservices live and do their thing. And then on top, you've got the presentation layer. That's the beautiful screen and user interface that you actually see and interact with as the driver. And make no mistake, this isn't just an engineering trend. This is a massive business transformation. Just like McKinsey says here, the real value in a car, what makes you choose one over another, is shifting away from things like horsepower and more toward the quality of the software and the user experience. So the big takeaway from all of this is that the very definition of a car has changed. It's no longer this static machine that's at its absolute best the day you drive it off the lot. It's now a dynamic, evolving piece of technology. It's a powerful computer designed from the ground up to get smarter, safer, and just plain better over time. And that leaves us with one last kind of mind-bending question to think about. When your car's performance, its safety features, maybe even its personality, can be fundamentally changed with a software update that happens while you're asleep, what does it really mean to own a car anymore?